Hello, everyone. My name is Tural Gulmammadov, and I'll present with Grace, and we'll talk about machine learning lifecycle with Oracle's cloud infrastructure today. Quick outline, like what we are going to talk about today. I'll introduce ourselves, then I'll start talking about generic machine learning lifecycle. I'll also touch the components of a typical machine learning system. So what are the components involved in the machine learning systems? And I'll introduce a couple of Oracle's cloud infrastructure services, which can be very handy for building and managing your machine learning systems. And also I'll present you one of the example machine learning solution architecture end-to-end, so you can give you an understanding from a network level how the things looks like. And then Grace will demonstrate a couple of services and how do they work within the Oracle's cloud infrastructure context. And then we will be happy to answer your questions. So Grace, she has been working as a data science intern in my team here at Oracle. And she's also an undergraduate student at Cornell University. Myself, I manage a team of data scientists and machine learning engineers at Oracle. Cool. From a generic machine learning lifecycle point of view, we can conceptualize this whole machine learning lifecycle in a various different ways. This conceptualization would be one way. So here, as you see, I split everything into three main components. One main component is about data and data management. We can think this as a data operations. Data operations consist of, first of all, identifying the right data sources for building a proper machine learning system, because your data should be predictive enough to give some capability you as a data scientist or a machine learning engineer to model that and fit it onto a particular model so it can make sense. So after identifying the right data sources, what needs to be done? You need to be able to ingest this data to somewhere. It can be your data lake or it can be your data warehouse, depending on your use cases. But you need some sort of mechanism to ingest your data. And after ingesting the data, you need to clean your data and do some sort of transformations. Again, it can be happening in your lake or in your warehouse, but the fact that you need some sort of a cleaning and the transformation, it's there. And after cleaning your data and transforming your data, now you need to explore the data and understand the data, because as a data scientist, we spend majority of our time to do this exploratory data analysis stage, right? We need to understand the data, how the data looks like, how the distributions are, and etc. And after that, there's a feature extraction for a typical, like not neural network type of perhaps modeling, for a typical statistical learning type of use cases. You will need to do feature extraction to understand what features are useful, and perhaps you might need to cut some of your features and not use them. And then after finding the right set of features, the next stage is about modeling, right? So in a careful cross-validated fashion, you need to train and test your models and tune the parameters of the model to get the best, quote unquote, best model out of your modeling box. So let's say after finishing this exercise, now you have an artifact of the model, which can be deployed to serve your end users and customers. And these days, everyone deploys it as a REST APIs, so we need some sort of mechanism to deploy it. And after the deployment, there is a monitoring aspects of it, because in the real world machine learning systems, if you observe the performance of the model, you can see that after, let's say, 5 months or 10 months or like around a year, perhaps, you might see some sort of a drift in your model. And in order to resolve those issues and in order to solve those problems, you might need to get back to your data management components. And start from one of those components. Like it might be the case that you need to have additional data sources, or it might be the case that you haven't done your cleaning job properly, or it might be the case that you need to extract new features or remove the previous features. So this is the whole end-to-end machine learning lifecycle. So what's the typical machine learning system would look like? So what are the components of it? In 2015, a group of engineers at Oracle, a group of engineers at Google, they have identified the associated technical debt with the real-world machine learning systems. Building a machine learning system, it doesn't come without any cost, right? So as you can see in this diagram, there is a small part which is about writing machine learning code. The writing code is super important. However, there are other aspects of this whole system which we need to pay more attention to. Like some of them would be serving infrastructure, how you are going to serve your model, how you are going to make sure the latency, how you are going to make sure that that serving infrastructure can scale. And monitoring is another important component because, as we have been discussing, right, and after some time, you might see that the distribution of any certain variable that's very important for your model might change. The distribution might change, or you might see that there is like a software level bugs or software level problems that's occurring in your system. So in order to resolve those issues in a timely manner, you need the proper monitoring infrastructure. Another super important part that at least we use in our day-to-day work is like how to identify which features we want to extract, because you need to understand the business in order to come up with this creative features, right? And if you don't know those features, like for example, if you are making a time series analysis, it might not be very obvious that you need to extract some sort of a spectral features from your signals, right? So in order to identify and understand that, and in order to be able to play with feature extractions, extract those new features and fit it into your model and test and train, so you need to pay attention to that part as well. In an enterprise environment, time to time, what we have been seeing that our customers, they don't want to use like out-of-the-box models, right? What they want is they want some sort of a configuration capability on top of the existing the machine learning system, where they can change the configurations, they can change the models, they can change the hyperparameters even. So giving the configuration capability to end user, we find that that's also super important as well in our work. And in this paper, the Google engineers, they also find out this is the case for their use cases as well. So within Oracle's cloud infrastructure, there are a bunch of different like out-of-the-box services that can be helpful. For example, I'm going to refer to OCI, to Oracle's data cloud infrastructure, moving forward. OCI has a data science services. One of them would be notebook service. In the notebook service, you can create, you can basically pull in your data. It's this typical Jupyter notebook. You can play with it. You can explore the data. You can build your models, and etc. After building your model, you can extract your model and put it to the artifact repository. So that repository serves as a storage for the machine learning model specifically. And after putting your model to the artifact repository, you can use Oracle, you can use the data science model deployment service and deploy models automatically. And the model deployment will generate, automatically will generate a REST interface for that. Grace will demonstrate that, and we can talk about it more. And other important services in order to build machine learning systems within OCI is OCI's object storage. OCI object storage is the same as AWS S3. So it's storage where you can store your files and your data, and it's a distributed data storage. So it comes handy for the big data-based machine learning systems as well. OCI data integration is very handy when you want to ingest your data to from multiple different sources to your sinks. One of your sinks could be object storage, another sink could be Oracle's autonomous database, or any sink it can be. And the data catalog, I find it very useful as a service. Data catalog helps us as infrastructure builders as well. So it helps us to make sure that the lake that we are building on object storage, it has a difference from the SWAMP. What I mean by that is it helps us to explore the data within the lake. So we can store our data within object storage, and within the data catalog, we can find the data, we can see where the data was coming from, we can get some metadata about the data, and we can identify the right data for our experiments. And from there, we can go to the notebook session, pull the right data, and do our experimentation and learning. So this would be one of the example solution that if you are using OCI services, you can easily integrate into your solution base. So here's the idea is that everything that I have been giving examples in the previous slides, that data science services, object storage, Oracle's autonomous database, data catalog, data integration, everything lives from a network point of view, everything lives within your VCN, like a virtual cloud network, right? And you can, from the multiple different data sources, you can ingest your data to your storages through data integration. And if you have like a streaming data, right, you might have some events and you might have some streaming data. You can also ingest it using the streaming service. Oracle also has data flow service, which can serve as a Spark cluster manager, basically, where you can run and schedule your Spark jobs. As a part of this presentation, I'm not going to talk about how to use data flow service or how to run Spark jobs, and etc. We're going to talk about more small-scale training jobs. And those small-scale training jobs can be achieved within the notebook session. And once your notebook session trains on the data, you can push that artifact from the training to a model deployment. And this model deployment will provide a REST interface. So whenever your end user or any enterprise-level applications, they need some sort of an intelligent insight, they can make the request through the VCN, and through API gateway, they can access the model. Within OCI also, there are some out-of-the-box AI services, like a language service, vision service, and etc. Again, that they are out of scope within this particular topic. Okay, so I believe we still have time, so I'm going to let Grace to continue and to demonstrate a couple of the things that I have been talking about.
Here's Oracle Cloud, and in this demo, I'll be showing some of the services that Oracle Cloud has that Tural talked about earlier. So when you create a model, you might want to store some of your data in OCI object storage. So here you can create a bucket, and for this, you can create a bucket using this one, and then once you create a bucket, you can go in and here you can upload different objects to the bucket. So for our data set, we only have this iris.data file. So we basically uploaded this file here, and then we will have it to use in our notebook. And once we have all of the data that we need in our OCI object storage, we can go to Analytics and AI, and then Data Science. And here we can get to our project. And in this project, we can create a notebook session. And so after creating a notebook session, you can open this notebook using this, and you can open it here. Tural, I think I might need the pen for the notebook.
Yeah, sure. 1 second. Yep.
Okay, cool. So after opening the notebook, you get to this page. Basically, here you can basically create a new notebook with like a new Python notebook with a specific environment, or you can create a text file or open a terminal tab. And then you can also create and open this environment explorer tab. And here you have different content environments that are built in already, and you can install them. And then so when you start your Python notebook, you can have all of these libraries installed. And so in this notebook, you can first retrieve the data from OCI object storage. So before we had the iris.data file, and we can get that from OCI object storage using different methods, and we can change that into a form that we want. So we want it as a data frame. So here's our data as a data frame. And then like a Jupyter notebook, you can also look at the data through printing out different values and like creating graphs. so here we evaluate the different features of the irises using the graphs, and then we also look at the relationships between the different features. And then also in the notebook, we can create the model. So we use 3 different types of machine learning models and use k-fold validation to choose our final model, which is a naive Bayes model. And then after we create this model, we can create a pickle file for the model, which is this nb_model0.pickle file. And so now that we've created a file, we want to be able to deploy it. And so to deploy it, we need a runtime.yaml file and a score.py file. So this runtime.yaml file basically tells model deployment what environment we want for deploying this model. Since if we use an environment in our notebook, we would want the same environment for when we deploy the model, so it has all the libraries it needs. So that's what runtime.yaml does. And then the score.py file basically loads the model and uses the model to make a prediction. So here we have the model that we created, and then we can use that to predict for a given input. And so that is our very simple model. And then going back, after we've created that model, folder with those 3 files, we can create a model. And in this model, we can just upload the model artifact. So we have to create a zip archive of the files that we need. So the runtime.yaml file and the score.py file, as well as the model itself. And then we get our model. And so our iris_model is our model. And then afterwards, we can create a model deployment. So in Oracle Cloud, we have different VM shapes and limits that you can choose, and you can choose a combination of these shapes, these shapes and the number of OCPUs that you want, or number of instances. So this is all customizable. And you can also choose the logging configuration, which basically stores information about your model deployment.
Yeah, and just one more point. Sorry to interrupt you, Grace. Like when you create a model deployment, right? You can easily select how many number of machines you would like to deploy on, and basically the scaling capability will come automatically. So you might say that, oh, I need like a 4 VMs, 2.4 shaped VMs, and what will happen is the more the load will increase from the application. So the more machines will be added to your model deployment. So by this, the scaling will be achieved.
Mm-hmm. Yep. And then so once you deploy the model, you can invoke your model. And so Oracle Cloud model deployment provides the HTTP endpoint for your model, as well as the OCI CLI, and then Python SDK and Java SDK. So you can use all of these to call your model. And here we use the Python SDK to call our model. And then we can just copy and paste this code directly into our notebook. And when we run it with this input, we get our prediction for our model. So yeah, that is a basic overview of some of the services and features of Oracle Cloud.
Yeah, so the good thing is that this will create this REST interface automatically, and will provide the ways to kind of call either through curl commands or through like a Python SDK or through Postman or whatever. Now your model is ready to be served, so you can easily configure your web application to make a call with a particular request structure and take the response back and parse it. Yeah.
What features are offered to manage model versioning and comparisons?
Okay, in terms of comparisons, there is not any feature for that. But for managing the versions of the models, you can use the model artifact repository. And within the artifact repository, you can see that you have it's like a typical repository. And you can see the different versions of your models and artifacts, and you can manage it as it is. So it's like you have a separate exclusive storage for your models to manage the versions. But unfortunately, there is not much for the comparison.